Kia ora, Year 12. This question is for Jackson, and it's based on one in the Walker workbook from the weekend's homework. This is the skill that we were looking at in class today that I think a fair few of you found pretty hard to start with. The good news is when you've done a couple of these, they should start to feel quite easy. We have to figure out here what the mean of a normal distribution is when we're given the standard deviation and a probability. So the context here is the number of hairs on an adult's scalp. And that number is normally distributed with a standard deviation of 18,000 hairs. So we can write down straight away, sigma is equal to 18,000. And then we're told that if 85% of adults have got fewer than 120,000 hairs on their scalp, find the average number of hairs on an adult's scalp. So we're looking for the value of mu, and we're told that 85% have fewer than 120,000 hairs. So X is the number of hairs, big X is the thing, right, the real life thing. Big X is less than 120,000. The probability of that happening is quite high, it's 85%. So we can write that statement down, and then we're going to draw the graph with the X, right? So it doesn't matter, you don't need to get it exactly right, but roughly we're going to have this all coloured in. This total area is 0.85, right? And we know that this number here is 120,000. And we know that sigma, the spread outness, the standard deviation, is 18,000. But we don't know mu. So that's cool. And if we're doing this on the graphics calculator, that's as far as we need to go with thinking about the coloured in picture. Sorry, I just have to colour that in a wee bit more. There we go. If, Jackson, if you're watching this, if you're going to use a normal table, we have to take one more little step. And that's because when we work with the normal table, the formatting means that I'm not given this area as well, right? So I don't have the whole 0.85. So before I kind of dive into the question, I have to go, well, if the whole thing is 0.85, we know that there's 50% on each side of the mean. So if that bit's 0.5, then the bit we're after here is 0.35. And that's quite a common kind of sticking point when people start doing these questions without a calculator. Okay, but let's go back now to the first slide. So what we've got to do is we can't use a calculator directly to say this. But what we can say is that we can work out from the probability and this number, what this is, by going down here and working with a standard normal random variable. And remember, the standard normal random variable has 0 for its average, and it has a standard deviation of 1. So what we're doing is we're taking the thing and we're kind of reshaping it, or keeping the same shape, and we're turning it into a standard normal. What that means is that I can use my calculator or my tables to say if there's 85% here, what does that mean about how many standard deviations above the mean I am? So that sounded complicated, but it's actually pretty easy to do. So we're looking for this Z value here, and it's got to correspond to the 120,000 up there. So the way that I do this on my graphics calculator is that I go stat, and then I go to dist, and then to norm for the normal distribution. And now I want to use the inverse normal because I've got a probability and I'm looking for a value of a thing, right? So we're going to make sure that when it says data, our data is being entered in variable form. That should be pretty obvious by now. Then for the area, I'm going to say 0.85. For the tail, I'm going to say left. And then I'm going to have mu of 0 and sigma of 1. Now, students who haven't practiced these questions enough will find that this is one of the places where you kind of get this far and then you come to a blank and you're like, oh, what do I do for mu and sigma? Well, because we're working with Z, the mean is 0 and the standard deviation is 1. Then I hit execute or exe, and the number you get out should be something pretty close to this, right? So 1.036433. I actually cheated and did this with a spreadsheet instead of doing it with my calculator, so it might round a tiny bit differently. So that is my Z value. right? Jackson, I'm going to finish this doing it with the graphics calculator first and show you where we go from here. So we've got the Z value. What that's telling me, let's just clean up some of this, is that this 120,000 is 1 and a tiny bit standard deviations above the mean, right? So we can put this 1.036 on here and see what's going on. Let's just get rid of some of this mess. So here, what we're saying is that when we draw our corresponding Z picture, the 120,000 represents 1.036 standard deviations above the mean. So now we're going to reverse engineer it and we're going to figure out what the mean is. And the way we do that is we say the link between the X and the Z is this. The standard normal Z tells me how many standard deviations above the mean I am. So we're going to substitute in 1.0364 is equal to X, 120,000, minus mu, the thing we don't know, the mean of the number of hairs on your head, divided by 18,000. Now we're going to do Year 9 algebra. We're going to times both sides by 18,000. And we get this left on the right-hand side. In class, we looked at doing this a really slow way, and then Jack said, well, actually, can't we just subtract or add? And we can, as long as we're carefully watching which one we want to do here. My mean here is going to be smaller than 120,000. Okay, so when I work these numbers through, I'm trying to think what that gives me. This gives me 18,655.8 on this side. And so mu is equal to this number. Take away this number. Which gives me 101,344.2 average number of hairs, which is kind of a stupidly precise answer, right? So I'm going to round that. Well, I'm going to round it to the nearest hair. Sometimes in a question, they'll tell you how many significant figures to do. And here you might end up doing maybe 4 significant figures, which would be more rounding, but kind of looks more sensible. Right, 2 more things for me to do in this video. I'm going to go through how to do it with the table, but I'm first actually going to do all the algebra steps for how we do this if you're not confident about just jumping straight to that step. So we've got 18,655.8 is equal to 120,000 minus mu. The first thing I'm going to do is what I did in Year 9. I'm going to collect all my numbers up on one side. So I'm going to subtract the little number from both sides. That's going to give me 0 is equal to 120,000. That's too many zeros there. 120,000 minus mu minus 18,655.8. Then I'll get 0 is equal to 101,344 minus mu. And now I'll add mu to both sides. So that's a slightly better way to do it than the thing that I did near the end of class today. We have to answer in context. So this is the average number of hairs on a human scalp. I have no clue if that's actually accurate. It shouldn't be too far off. That's a lot of hair. Right, lastly, Jackson, I'm finally going to show you how to do this with a table. So let's go all the way back up to here, because the only tricky step in here is how we get the Z value, and then everything else is going to be kind of the same. Okay, something weird just happened with the recording. Tell me if you can't hear this. Okay, so we've got this, and I've said this already before, but I'm going to say it again. If we've got 0.85 here, we have to get it into this format here. So now that we've got 0.35, what I'm looking for in the table is I'm hunting through the middle part of the table to find 0.35. And I'm going to have to use the painful little column over here. So looking through here, I can see that I'm getting close to 0.35 but I get really close about here, right? So this number is 1.03. So this number is a wee bit too low. So I'm going to go over here and I'm going to add my add factor here. I'm looking for about 15 because 85, to get that up to 100, the gap there is 15. So you can see 14's here, 16 is here. I'm going to go with the 6, and that gives me 1.036 for my Z value. Right, and you'll see now that if we go back to that last slide, we're good to go. We've got Z. Our Z is not quite, let's see, what did I get for my Z? Yeah, 1.036. So it's not quite as accurate as doing it from the computer or the calculator, right? But you'll get to a very, very similar answer. So then you just work through from there. So the tricky bit with the table is getting the Z value, but hopefully that helps. So send me some more emails, guys. If you are stuck, Jackson, it was great that you asked me for help with that question. I'm sure there's a bunch of other people in the class who need to watch this as well. Have a good weekend, everyone.